I don't think I could have found a smaller switch to demonstrate this, so that's fun. Being the fact that we work mostly in commercial vehicles and the switches are quite a bit bigger than this. I'm not sure why I'm using this one, but sure, let's go with it. The principle is the exact same. This one here, what we can see is that it's a toggle switch in 2 positions, and this tin plate actually says both on here and on here. So this switch is on in both positions. Now, what do we mean by on in both positions? Well, the power, let's say we were controlling the positive side of the circuit. The positive would come into this center post. And as we move this switch, we're actually making contact, so I'll use the seal pick, we're actually making contact with that post right there. So in this switch position, that center post makes contact right there. Now, if I move the switch to the other side, now it's like a lever that gets pushed over, and this contact, the center, makes contact with this terminal. And so what that means is through this type of a toggle switch, I am sending the voltage from that center terminal, the current, to either this terminal or this terminal. If this was a hydraulic valve, we would call it a diverter valve. It's sending to either one terminal or the other, but not both. Now, if you look at this, you'd say, oh, there's 6, not 3 terminals. What's the story with that? Well, this is actually 2 switches put into one body. So we would call this a double pole. And since there's 2 electrical positions, it could be in this one or this one, it's called a double throw. It's a very common switch in the transportation, automotive, commercial vehicle, mobile equipment industry. So this is a double pole, DP, double throw, DT switch. Now, each of these circuits, this one and this one, are independent of each other. So if you want both of these center terminals to be positively powered, you would actually need to run a wire to both of them. And I'll show you that they're independent right now by just hooking up our ohm meter, sliding this under, and we can see that even with that connected, we are still reading OL. Now, if we connect up here, we can see I have continuity, and if I move the switch position, it goes to OL. Move that over to the other switch, and it reads OL. Now, why is that important that we talk about it? Well, that is the diagnostic test you would do, because you may have that this switch operates 2 different devices, and one device works and the other one does not. And so what you need to check is to make sure that the continuity on one side works. So you'd say, okay, move the switch. Okay, it's working fine. Well, mechanically, that means this other circuit should also have continuity. And it does. So if for some reason one side was working and the other side was not, that would be an indication that internally in the switch there was either enough arcing, enough resistance buildup, enough vibration that that switch has failed in the open state. So anytime you're expecting continuity and you don't get it, anytime you're expecting that number to be 0, and instead it's OL, that is an open. Anytime you're expecting that to be OL and you get a number instead, that's a short. All right, so that's why we need to be familiar with these switches. Not so much that we need to memorize all the different things, but we have to be aware of what they are, how they operate, so that we can actually perform the tests.